Good day. We are moving on from those diagrams about stoich, and now we're looking at some simple questions related to mole ratios. What happens here is I have 2 moles of this, and if I want to find the amount of any other material, whether it's a reactant or one of these products, I have to take this number of moles and multiply it by the mole ratio. The mole ratio in this case is always you look at the destination, the unknown, its coefficient, and you divide it by the coefficient you're starting with. So here I'm looking at 2 times 5 divided by 1, so I get 10.0 moles. So I went boom, multiply by 5 divided by 1. I'll go here, 2 times 3 divided by 1, and I get my 6.00 moles, and the last one I go 2 times 4 divided by 1. So we always multiply by the coefficient where you're going, what you don't know, and divide by the coefficient of where you're starting from. So we do the same thing for here. Now we have 25 moles, and we're going to multiply it by 1 and divide by 5. And so there's our 5 moles. Now I go 25 times 3 divided by 5. And then I go 25 times 4 divided by 5. So this 4 divided by 5 is called the mole ratio. In this case, I'm starting with the product. Doesn't matter. So this is what I know. Its coefficient is 3. I'm going to multiply by 1 divided by 3. So to go from here to here, my mole ratio is 1 divided by 3. And so 0.8 times 1 divided by 3, 0.267. Here, times 5 divided by 3. And last one, multiply 4 divided by 3. Now, to fit things on the screen, we got a few more here. I'm starting with the product here, so I'm going to multiply by 1 divided by 4. Net effect is divided by 4, but mole ratio 1 over 4. There it is. Now I'm going to multiply by 5 divided by 4. And finally, I'm going to multiply by 3 divided by 4. So that's trying to illustrate mole ratios. We'll get more exotic, but this is going to show us the level, how you can move anywhere from mole of one material to another by respecting the coefficients and figuring out mole ratios.